Go ahead and add goal 1.4 notes to your table of contents. Goal 1.4 is going to be about finding protons, neutrons, and electrons in what we call a given isotope or ion using your periodic table. So we'll learn what those two terms mean, isotopes and ions, and we'll learn how to predict or calculate exactly how many protons, neutrons, and electrons a given atom, isotope, or ion has. So the first thing that we need to know is how to find the number of protons. And we find that by the atomic number. So the atomic number equals protons. This is what tells us what element an atom is. So for instance, if I have an atom with 6 protons in its nucleus, that means that it is atomic number 6, and that happens to be carbon on the periodic table. So the number of protons changes what element you are looking at. Notice that if you look at the periodic table, every single element on there has a different atomic number, meaning a different number of protons in the nucleus. Okay, now let's talk about isotopes. So isotopes are atoms of the same element that have different masses. So if we look at this image here, we notice that each of these atoms would be considered carbon because they have 6 protons in their nucleus. So these orange particles that you see in each picture, those are those are the protons. And if we count them in each picture, we see that each one has 6. Remember that the protons are the atomic number. That's what makes it the element that it is. So each of these is carbon. As we look at the picture on the far left, we'll call that picture A. We notice that it also has 6 neutrons. The number of protons plus the number of neutrons is the mass of the element. So this particular element would have a mass of 12. Sometimes you'll see it called atomic mass or atomic weight, or this one says nuclear number. Whatever it's being called, it means the same thing. And in this case, the mass would be 12. In picture B, we have 6 protons. That means it's carbon. Then we have 7 neutrons in the nucleus. That changes its mass to 13 because it has one more particle in the nucleus. And then if we look at picture C, we add even one more neutron to make it 8. That gives us a total protons plus neutrons of 14. So each of these atoms is carbon, but these are each a different isotope of carbon. The first one is plain old carbon. We call it, sometimes you'll see it called carbon-12. It's the most common isotope of carbon. The second one, we call it carbon-13 because it has a mass of 13. And then picture C, carbon-14 because it has a mass of 14. Okay, so it brings us to an important equation. Mass equals protons plus neutrons. This tells us what isotope of a particular element that we're looking at. Isotopes, like you just saw, have their mass listed after their name, usually. So some examples, carbon-14, uranium-241, nitrogen-15. If you see that number that comes after the element name, that tells you the mass of that particular isotope of that element. Okay, after regular atoms, isotopes, we now are going to go and talk about what we call ions. Ions are atoms that have a charge. Now, if we go back and think about what we learned in our previous learning goals, we learned that electrons have a negative charge, protons have a positive charge, and neutrons do not have a charge. So when we think about ions, we think about protons and electrons, those positive charges, those negative charges. They won't always equal each other. They won't always balance each other out. For instance, if I have an atom that has 6 protons and 6 electrons, the positives and negatives are balanced, so that atom is neutral overall. It is neutral. If we have an atom that has 5 protons and 6 electrons, that means we have one less positive charge than negative charge. That would be a negatively charged atom. And in more particular, its charge would be -1. Okay, so here we had 0, no charge. Here we have -1. In the third picture, we see we have 6 protons and only 5 electrons this time. So that means we have more positives than negatives. This atom would be positively charged. And even more specifically, its charge would be +1. So this brings us to another important equation, and that is, what did I do there? Here we go. And that is charge equals protons minus electrons. So if we don't want to know the charge of an atom, we take its number of protons, the positives, we subtract its number of electrons, that gives us the charge. An atom with a charge, again, is called an ion. All right, so here's the main 3 equations that we're going to use. Atomic number equals protons, mass equals protons plus neutrons, charge equals protons minus electrons. Sometimes you're going to have to rearrange these equations to make them more relevant to the problem that you're solving. For instance, if we take the mass equation, sometimes we will be given the mass and we will know the number of protons, but we won't know how many neutrons. So we might rearrange it to say something like mass minus protons equals neutrons. Same with charge. We might have to rearrange that sometimes. Maybe we're given the charge and we're not sure how many electrons we have. We would have to rearrange that equation accordingly. All right, isotope notation. This is something that you'll see in your packet, and this is important to know. So you might see an element or an atomic symbol, and it looks something like this. And it's got some numbers and maybe a positive or negative sign, and that's pretty straightforward. What this means is we're basically summing up everything about the atom in one little picture. So obviously Na, that's going to be the symbol of the element, so you'll see the symbol in the center. The top left number is the mass, the bottom left number is the atomic number, and in the top right is the charge. If you don't see a number, just a plus or a minus, that you can assume that it's +1 or -1. If there's nothing in the top right, we can assume that it's a neutral atom. And again, charge equals protons minus electrons, mass protons plus neutrons. Let's do an example here. We've got isotope notation right here. Okay, we have 4 in the top left, 2 in the bottom left, +1 in the top right. We want to know how many protons, neutrons, and electrons that we're working with here. This is He, which happens to be helium on the periodic table. We see that its atomic number here is 2. That tells us how many protons. Remember, atomic number always equals the number of protons, so we can put 2 for protons. Neutrons, we know the mass and we know the protons. Remember that protons plus neutrons equals mass. We can use that information to figure out how many neutrons this atom has. So the mass we know is 4 from right here. We can subtract the number of protons, which we know is 2, and that's going to give us the number of neutrons. And in this case, 4 minus 2, so we have 2 neutrons. This particular atom has a charge of +1, meaning it is an ion of helium. And we can use that information to figure out how many electrons we're working with. Remember, charge equals protons minus electrons. Pardon my terrible handwriting there. And we know that we have 2 protons. We know that the charge is +1. Okay, so +1 equals 2 minus what? Well, that's got to be 1. And that makes sense because if we have 1 less electron than proton, we would have a charge of +1. We'll do one more example here. Now we're working with Si, that's silicon, mass of 26, charge of -3, and atomic number is 14. Right away, we know the atomic number. That means we know how many protons it has. We can jump to the number of neutrons. We're going to find that out from the mass. Okay, the mass is 26. We know that 14 of those particles that make up the mass are protons, which means that 12 of them, 26 minus 14 is 12, 12 of them must be neutrons, because the protons and the neutrons have to add up to the mass, which is 26. Lastly, the electrons. This time we see that our charge is -3. Remember, charge equals protons minus electrons. Okay, so we have -3 equals protons, 14, minus what? So how would we get to -3, right? 14 minus what is -3? Now think about this. It's a negative charge. That means you have to have more electrons, more negative particles than protons. And more specifically, you have to have 3 more electrons than protons. So if we have 3 more electrons than we have protons, that means we must have 17 electrons. 14 plus 3 is 17.